So why do we need to complete the square for a quadratic expression? Well, one example is in graphing. What we can do is rearrange the quadratic expression for ease of finding some key features of the graph. So we can see here if we complete the square for this expression, we've got the coefficient of x is -4. So we'll half that and place it in the bracket so we get x minus 2 all squared. And the dots indicate that there's more work to be done. So the next thing we do is we subtract the value in the bracket squared, so in this case minus 2 squared, and then we add the constant at the end, so that's the plus 5. And if we simplify that, we're left with the equation y equals, in brackets, x minus 2 all squared plus 1. Now, matching to the graph, that shows us a key feature. The turning point of the graph with the same equation is the point 2, 1. And you'll notice those values come up in the equation that we've just formed from the completing the square version. In fact, a summary of that is that we have, for any graph expressed in turning point form, y equals x minus p all squared plus q, the turning point is pq. In fact, a more general form for completing the square is y equals a brackets x minus p all squared plus q. And that, of course, covers the instances where the coefficient of x squared is not equal to 1. Nonetheless, in that form, the turning point is still the point pq. Let's have a look at another case where we might want to use completing the square, and that's where we have to find exact solutions to solving an equation. In this case, we've got to solve x squared minus 6x plus 4 equals 0. Now, of course, the first thing we'll try is to factorise, but it may not always work exactly. So what we do is we complete the square, and we do that by following the same process. So the first thing we consider is the coefficient of x, which in this case is -6, and we halve that, so we get -3, and we place that in the bracket with x all squared. The next thing we do is we subtract from the bracket 3 squared, in other words the value that we've actually placed inside, so minus 3 squared, and then we add the constant from the original equation, which in this case is plus 4. Simplifying all of that, we get x minus 3 all squared minus 9 plus 4 is equal to 0, or x minus 3 all squared minus 5 is equal to 0. Now we go to solve the equation. Now what we want to do first of all is remove the minus 5 from the left hand side and take it to the right hand side, so we get x minus 3 all squared equals 5. Then what we do is we take a square root of both sides, so we get x minus 3 is equal to plus or minus root 5. Then we shift the -3 from the left hand side to the right, it becomes positive, and we get the solutions are x equals 3 plus or minus root 5. So completing the square has enabled us to find some exact solutions that we wouldn't have been able to find normally using factorisation.